2015 JEE mains question is like this given. Is a tricky way of constructing the question like this. A pendulum having time period t seconds. How much mass added to produce new time period T2. Let it be previous T1, now it is T2. How much mass is added to produce time period T2 having where Young's modulus Y, they given like this. How to do this type of problem? Time period of a simple pendulum, everyone knows about this. Look at here please. This is the simple pendulum of mass is m. Length is L. I don't know previous, after extension is this much. Then T equal to 2 pi square root of L by Z. This is well known thing to us. Some additional mass is added to it. Let it be delta M. Because of additional mass, now your length is not L, that is L plus delta L. This is the twist related to elasticity. Twist given based on elasticity. Now that is T2 equal to 2 pi square root of L plus delta L by Z. They are asking us mass required. Mass means, I think so you can do it like this. T2 by T1 equal to square root of L plus delta L by L. If I divide the 2, T2 by T1, then I am going to get like this. Squaring on both the sides, T2 by T1 whole square equal to, that is L plus delta L by L. Yeah, very good. I think so you can understand. T2 by T1 whole square minus 1 equal to delta L by L. I think so you understand. You identified your term. Delta L by L is what? Strain. Before that, once again going for strain of elasticity link. Let us suppose the string is having length L, mass M, then time period is 2 pi root of L by C. Because of some additional mass, there is extension in the wire delta L, L plus delta L. Then time period T2 equal to 2 pi square root of L plus delta L by Z. T2 by T1 equal to root of L plus delta L by L. Then I got like this. Suppose if they ask us like this, strain I required, you know very well, Y equal to mgl by AY or AE. Strain I required, E by L equal to YA upon mg. YA upon mg. Mg, whatever the added mass or final mass, what it is, mg. Then E by L is what? Strain. Now that is YA upon mg equal to, from this please substitute it, 1 minus T2 by T1 whole square. They asked what? M or M plus delta M, whatever it is, M dash or whatever it is, that is M dash equal to, bring this to this side, that is 1 minus T2 by T1 whole square into G upon YA. I think so actually they asked 1 by Y, but I got M dash based on my question answer. Once look at it please. A pendulum having time period T1 seconds. How much mass is added to produce T2 having the wire Young's modulus is Y. Y. Yeah, right, look at it please. Length of the pendulum is L. T equal to 2 pi square root of L by C. If I extend because of mass, additional mass delta L, this is having connectivity with your elasticity. T2 equal to 2 pi square root of L plus delta L by C. T2 by T1 I required. L plus delta L by L. Squaring on both the sides, I got like that. This is T2 by T1 whole square minus 1. Delta L by L, I think so you recognize that it is what? Strain. From the definition of Young's modulus, Y equal to mgl by AE, E by L equal to Ya by mg, then I got m dash is the produced mass. This is a beautiful application with a simple pendulum. Yeah, right. Once we think about simple pendulum, one more beautiful application given in the advanced papers of JEE. Right, look at it please. This is a wire, elastic wire of Young's modulus is Y, and area of cross section is A, length is L, is attached to a string of length L, mass M. This combined system is set into oscillation. Then how to calculate the time period of this system? Please understand this. This is having the bar Young's modulus Y, and this is having connectivity like this, spring constant K. These two are how they are end to end connection. End to end connection means a series arrangement. Yeah, in series, students, I think so you know about this. Extension equal to x1 plus x2. Total extension equal to sum of the individual extensions. Yeah, right. Then that is f equal to kx, f equal to kx, x equal to what? F by k equal to f by k1 plus f by k2. Here series exerting force is the same, f cancelled, 1 by k equivalent equal to 1 by k1 plus 1 by k2. Yeah, apply this equation to our connecting question. K2 is given as a spring constant 1 by k, but another is what? Elastic wire. How to find the spring constant of this wire? That is Y equal to FL by A delta L. Delta L is extension. That it is Ya by L is F by delta L. That is nothing but K. This is a spring constant of this wire. Then I required reciprocal of K, 1 by K, L by Ya. L is what? Length of this wire. Then 1 by K equivalent I got. So K equivalent, I think so you can understand it's very easily. K equivalent equal to LCM, make it LCM and reciprocate the term. YAK upon LK plus YA. Yeah, now this is nothing but a loaded spring arrangement. I can calculate the time period very simple. T equal to 2 pi square root of m by, instead of k I am going to get k equivalent. That is 2 pi square root of m, k equivalent, substitute that one, LK plus YA by Y into area into k. This is the time period of arrangement of this one. Till now observe this, maximum area of elasticity has connectivity with Young's modulus of solids. So beautiful applications we can find like this: elasticity, loaded spring and simple pendulum. Yeah. So we are continuing the applications of elasticity further. String of length 2L. String of length 2L. Young's modulus of the wire is Y. Fixed between the two rigid supports. Fixed between the two rigid supports. We observe this type of things in our house. A hanger is there. On that hanger, we suspend a weight. If I suspend the weight at its middle, let us suppose W is the weight, then this is the situation. In this case, how to find the strain produced in the wire? Strain produced in the wire calculation is like this. Strain equal to change produced per unit length delta L by L. Change produced per unit length delta L by L. Let us suppose this is the length L. Extension in the wire is Y along the Y direction. Here Y is very much smaller than L. Y is very much smaller than L. Then from Pythagoras theorem, the side length is like this, L square plus Y square. This side length also same thing, L square plus Y square, because it is an isosceles triangle. Delta L equal to new length minus original length. Delta L, new length to the original length, or extension in the wire to the original length, that is final length. 2 into this much, square root of L square plus Y square is the final length. Square root of L square plus Y square plus square root of L square plus Y square, 2 into L square plus Y square minus 2L, original length. This is the change in length. Strain I want to calculate. Strain equal to delta L by L, that is 2 into square root of L square plus Y square minus 2L by 2L, original length. This is general expression that I taken applied to for my diagram. This I got from delta L by L. My original length is 2L, that I taken as 2L. 2, if I cut it, 1 plus Y square by L whole square, whole power 1 by 2, L common, bring it out, minus L by L. If I take common L outside, 1 plus 1 by 2 Y square by L square minus L by L. L gets cancelled. Then strain equal to 1 plus 1 by 2 Y square by L square minus 1 cancelled. That is equal to Y square by 2L square is the strain produced in the wire. Based on this question, based on this topic, they can ask you stress. How to calculate stress? For stress calculation, I have to do like this. Stress, force per area. But force is, what is force here? Tension of this is towards the rigid support like this, T and T. This is making an angle theta, let it be. This is theta. I think so you can understand. This is a T cos theta t sin theta. This also t cos theta, t sin theta. T cos theta gets cancelled. 2t sin theta equal to w. T cos theta gets cancelled. T sin theta adding up equal to weight of the body. 2t sin theta equal to w. When theta is small, tan theta can be written as, sin theta can be written as tan theta. That is equal to w. T equal to w by 2 into theta. Tan theta equal to theta. From this, tan theta equal to what? Y by L. Tan theta equal to y by L. That is w by 2 into tan theta y by L. So now that is WL by 2y is the tension. So now I am not finding space, but I want to calculate stress. Can I write here? Stress equal to tension by area or force by area. That is WL by 2 into YA. This is the extension in the wire. Y is not Young's modulus. Y is the displacement here. Capital Y represents Young's modulus. Small y represents displacement known as vertical displacement. Let us see once again. Consider a wire of length 2L. At its middle, I suspended some weight. What is the strain produced in the wire that I want? Strain equal to change in length per original length. Let us suppose if it is displaced by y distance, then hypotenuse, Pythagoras theorem, square root of L square plus y square. Here also square root of L square plus y square. Change in length equal to new length or final length minus original length. 2 into L square plus y square. 2 into L square plus y square, I got plus plus. Minus 2L is the original length. Strain equal to delta L by L. But L is original length, mine is 2L here. Cancelled it to 2. I got like this after applying binomial approximation. Binomial approximation I got like this. Then next thing I want to calculate stress. Stress equal to force by area. 2t sin theta. How I got stress? Look at it please. T resolution. T cos theta cancelled. 2t sin theta equal to W. 2t sin theta equal to W means 2t into sin theta can be written as theta because theta is small. 2t tan theta W. T equal to W by 2 theta. W by 2 into theta equal to what? Tan theta y by L. Or arc length by radius y by L. Then I got like this tension. Stress I got T by A, WL by 2 into y by A. They can ask you like this, Young's modulus. Young's modulus means stress by strain. I got a stress, Young's modulus, stress by strain. Stress by strain. Stress equal to what? WL by 2 into small y into A. Take care, capital Y is Young's modulus, small y is extension along the y direction. Now that is strain. Strain equal to this much I got, y square by 2L square. If I bring it to numerator, that it is WL cube by 2y cube into A. They will ask us like this, vertical deformation in the wire. Vertical deformation in the wire. Y cube they can ask us. Y cube equal to WL cube by 2 into capital Y into A. Y equal to W of 2YA whole power 1 by 3 into L. This is one time given, I think so, in the old papers of advanced paper. Vertical deformation in terms of original length. They can put question to us like this. Okay. In this way they can put 3 questions based on this. One, they can ask us strain. Another question, stress. Another question, based on Young's modulus, vertical displacement with the length of the wire. Y is proportional to L because W and capital Y, capital A are constant. Y is proportional to L. This is the condition, very important thing you have to understand. Okay. This is one of the application of stress and Young's modulus based on conductivities. Next, I am thinking like this. Elasticity, Young's modulus, thermal stress. So why we can't think in terms of heat and thermodynamics? This is the wire having original length L. If I raise the temperature of this wire from T1 degree Celsius to T2 degree Celsius, if I raise the temperature from T1 degree Celsius to T2 degree Celsius, you know very well, because of rise in temperature there will be an expansion delta L. Linear expansion coefficient of your lower classes, change in length per original length per unit rise in temperature is called linear expansion coefficient. Linear expansion coefficient, change in length per original length per unit rise in temperature is called linear expansion coefficient. Delta L by L equal to alpha delta T. So, up to this part, heat. I want to give connectivity between heat and elasticity part. What is thermal stress developed in the rod? Thermal stress, Young's modulus of the wire Y, that is longitudinal stress by longitudinal strain. Stress equal to Y into strain. Strain I got already like this, stress equal to Y into alpha delta T. This is the thermal stress developed in the rod. Next, after this, they can put question to you, thermal force. Thermal force equal to, that is thermal force F equal to stress into area. Now that is Ya alpha delta T is the thermal stress developed in the wire in terms of thermal force. Based on this, I want to do one example for you. A wire is fixed between two rigid supports. Having Young's modulus, 2 into 10 power 11 Newton per meter square and area of cross section (10⁻⁻6) meter square. If temperature of the wire decreased from 40 degrees centigrade to 20 degrees Celsius, then stress produced in the wire a wire is fixed between two rigid supports having Young's modulus 2 into 10 power 11 Newton per meter square and area of cross section 10⁻⁻6 meter square. Sometimes they will give us like this 1 mm square, same thing. if temperature of the wire decreases from 40 degrees Celsius to 20 degrees Celsius, then thermal stress produced in the wire or stress produced in the wire. Just now I calculated stress equal to YA alpha delta T. In this case, they will give you alpha of the material, that it is, let it be 1.2 into 10 power minus 5 per degree Celsius. That is Y equal to 2 into 10 power 11 Newton per meter square. Area 10 power minus 6 meter square. Sometimes they will give you mm square. Mm means you know how to convert 10 power minus 3 whole square. And alpha 1.2 into 10 power minus 5. And that of change in temperature 40 to 20, that is 20 degrees Celsius. Now that is 2 10 power 11 minus 11 cancelled, plus 11 minus 11 cancelled, then 2 into 20 40 into 1.2. So now that is 48 Newton per meter square is the stress developed in the wire. In this way they can give direct questions based on this, like BitSat exams. Next, students, they will think about like this, that is, a string is passes over a pulley like this. It is basic one to us, attribute mission, and clearly we have idea about this. M1 is the mass, M2 is another mass, hang over from a pulley like this, massless pulley, and but the string is exchangeable, having Young's modulus Y, length of the string is L. They put question to us, stress developed in the wire or extension produced in the wire. How to do this? Based on free body diagrams of NLM, here I am giving like this, M1 greater than M2. M1G downwards, tension upwards, and the system is going downward with an acceleration A. Like M2 tension upwards, M2Z downwards, A is upwards. From these equations we can write like this, NLM equations. What is NLM equation says us? Body direction forces we have to consider positive, opposite is negative. Body direction forces we have to consider positive, opposite is negative. Then M1A equal to M1G minus T. Similarly, M2A equal to T minus M2C. Then TT gets cancelled, acceleration equal to M1 minus M2 in by M1 plus M2 into G is the acceleration. If I add the two, I will get like this. You can do it, I think so. Add these two equations, I am going to get like this. But actually I want to calculate stress developed in the wire, means tension I want. T equal to, from this second equation, M2 of G plus A, second equation, from second equation, T M2 G plus A, M1 minus M2 by M1 plus M2 into G. Make it common, M2G. M1 plus M2 plus M1 minus m2 by m1 plus m2. m2 gets cancelled. Then tension equal to, I got this much, 2m1 m2g by m1 plus m2. This is the tension in the wires. They will ask us like this, stress how to get? Stress equal to T by A. T by A means area of cross section they will give us. Then 2m1 m2 z by A into m1 plus m2. This is the stress developed in the wire. This is one of the application with Atwood mission. Like this, each and every connected body they can give you in the case of elasticity chapter connected to connected bodies. I want to give connectivity with pseudo force. Let us suppose this is the vehicle or trolley. A string of length L, extensible string of length L, area of cross section A, Young's modulus Y. Attached with a mass M, the system is moved towards right side with an acceleration A. Clearly this example is concerned to non-inertial frame of reference. Non-inertial frame of reference acquires the pseudo force whose direction is opposite to the original direction. Non-inertial frame won't acquire pseudo force. The objects which are inside the non-inertial frame acquires the pseudo force. Can I repeat my sentence? The objects which are available or attached to the non-inertial frame of reference acquires the pseudo force. So that is pendulum acquires the pseudo force. If I think about pendulum, tension is like this, pseudo force MA like this, MG like this, and the pendulum makes an angle theta with the vertical if they give. If the wire elongates, they can ask you extension in the wire. How to do this? Theta like this, T cos theta, T sin theta. From this, T cos theta equal to mg, T sin theta equal to MA, pseudo force. Then T equal to m into square root of g square plus a square. Here a is the acceleration of the trolley. Extension produced in the wire y equal to FL by A delta L. Y equal to FL by A delta L. Then extension E equal to FL by AY. F is what here? Tension. That is m into under root g square plus a square into L by AY is the elongation produced in the string because of pseudo force. This is one of the non-inertial frame of reference example. Once again I want to repeat it. Nothing is there. Very simple question, simple concept. They can construct in a tricky manner like this. If the string is extensible, having Young's modulus A, area A, Young's modulus Y, area A, length L, then system is set into right side motion with an acceleration A. This frame of reference is a non-inertial frame of reference. The objects which are available inside the frame acquires the pseudo force that it is towards right left side. MA, MG, tension towards the rigid support, T cos theta, T sin theta, equate the things. Squaring and adding the two side, squaring and adding the terms, we get like this. Elimination of theta, you know very well from your mathematics. T equal to m into square root of g square plus a square is the tension. Then I got like this. Suppose if they give like this, sometimes theta they will give us, pseudo force they will give us. How to find extension? E equal to MAL by AY into sin theta. like this. If they give pseudo acceleration, we can approach the problem like this. If in terms of weight, if you want, mgl by ay cos theta is the extension in the wire. This is one of the application of pseudo force.